Bismillahirrahmanirrahim. Assalamu alaikum, dear students. In today's lecture, we are going to discuss about the shielding effect and effective nuclear charge. So, in this topic, first of all, we have to discuss that what is shielding effect. Then we will move toward the effective nuclear charge. So, shielding effect is basically you people have heard the word shield, head shield. Head shield is the a type of cap that is. So, keep in mind that the word shield is something related to the protection. So, shielding effect is the decrease in the force of attraction on valence electron caused by the presence of the intervening electron. Valence electrons are the electrons that are found in the valence shell of the atom. And what is intervening electron? Actually, the electrons present in the inner shell of the atom. So here is the picture that is shown in front of you. So the electrons that are found in the last shell of atom are known as the valence electrons, and those found in the inner shells of the atom, there may be one shell, there may be two shells, there may be number of shells, but all those electrons that are present in the inner shell of atom, inner to the valence shell, these are known as the intervening electron. And keep in mind that shielding effect is operated on valence electron, but that is caused by the intervening electron. Basically, nucleus has positive charge and that attracts all the electrons towards itself. That is shown here. Nucleus is attracting this one electron, it attracts all the electrons. But what is about the electron present in the intervening shell and that in the valence shell? So as both the electrons are having negative charge, so negative repels the negative. So electrons present in the inner shells or the intervening electrons repel the valence electron. So there are two forces that are operating on this valence electron. One force is the attractive force that is pulling inward toward the nucleus, that is because of the nucleus, and the one another force is the force that is a repulsive force that is caused by the intervening electron or the inner shell electron, and that repel the electron away from the nucleus. As both forces are opposite, so the net force that is found on the valence electron is a combined effect of both these forces. And when the repulsive force caused by the intervening electron, you can say, operates, the attractive force caused by nucleus is reduced by a small factor. So next is the effective nuclear charge. So decreased nuclear charge sensed by valence electron because of the intervening electron or the inner electron is known as the effective nuclear charge. So here is the equation that is showing the value of effective nuclear charge. Z effective is equal to the Z minus sigma. So what is Z? Z is basically, you people know that Z is a symbol that is used for the atomic number. So Z is the actual charge and Z effective is the charge that is sensed by the valence electron, and that Z effective is small, is a bit less than that of the actual charge. Why? Because some of the nuclear charge is nullified by the intervening electron. So the nuclear charge that is sensed by the valence electron is a bit less than that of the actual charge. And how much it is less than? That is lessened by the factor sigma. So this is the symbol of the sigma, and that sigma is also known as the screening constant. The other name for the shielding effect is the screening effect, and this sigma is known as the screening constant. Sigma is also called the screening constant. So keep in mind that Z effective is a bit lesser than that of the actual charge by the factor sigma. So here are the two factors that affect the value of the sigma and that affect the value of the Z effective. There are two factors. One is the number of intervening electron or the number of inner electron. So it is shown here that sigma is directly proportional to the number of inner electron or the intervening electron. More is the number of inner electron, more would be the magnitude of the sigma, and here is Z effective is inversely proportional to the inner electron. More is the factor sigma, decreased would be the value of Z effective, because when higher value is subtracted from the actual charge, smaller would be the value of the Z effective. Z effective decreases down the group. When we are in the group 1A, the number of valence electron is 1 in all the elements. These are all the members of the same group. All these have 1 electron in their valence shell, but the number of intervening electron is not same in all these cases. Whenever we move down the group, the number of intervening electron goes on increasing. So look at here. If more electrons are introduced in the inner shell, so whenever the number of intervening electron or the inner electron would increase, the sigma factor would also increase and Z effective would decrease. The next factor is the size of the atom. Z effective is inversely proportional to the size of atom. Higher is the size of atom, more distant would be the valence electron from the nucleus, and lesser would be the force of attraction sensed by the valence electron. So Z effective is inversely related to the size of atom, and as you people know that down the group the size of atom goes on increasing. Just like here, when we move from hydrogen to lithium, sodium, potassium, down the group the size of atom increases, and as the size of atom increases, the sigma factor also increases, and the Z effective decreases in the same manner or in the same ratio. So this was all about the shielding effect and the effective nuclear charge. The next video would be on the Slater's rule. So if you have anything confusing in this lecture or in this video, you can post your question in the comment section. So we would meet in the next video. Up till Allah Hafiz.